Here's the information again for the top of these notes if you need it. Okay, if anyone needs it. Pause if you need it.
Stop it, girl.
And here's the information for the bottom of the front page if you need it. Pause it. Write it down. So parallel lines have the same slope, and perpendicular lines have opposite reciprocal slopes because they meet at right angles, which means we're going to flip the fraction and we're going to change the sign. Okay, now if we want to look at the relationship between different types of functions here, we need to determine if the lines are parallel, perpendicular, or neither, because not all lines are either parallel or perpendicular. If we look at the first example, the top line of the first example, what's the slope in the first line?
4.
What's the slope of the second line?
4.
Okay, so since they are both 4, what would we call these two lines? Parallel. So we're going to draw the parallel symbol for this number 1. You can also write the word parallel if you'd like, but you have a shortcut you can use, so why not? Okay. We're going to look at number 2. What's the slope of the top line in number 2?
-6.
-6. What's the slope of the second line?
1/6.
You totally do know. How did you know it was 1/6, Kayla?
Because it's an X next to it.
Technically, yes, there's still an X next to it. This is point slope form.
1/6 is where the slope is.
Correct. Y minus Y1 equal to M, your slope, X minus X1. So we still know our slope. So now, how are these two slopes related? Are they the same?
No.
Are they flip and flip?
Yeah.
Yeah, so these are opposite reciprocals. Flip over the fraction, change the sign, we get there. So these are called perpendicular. You can write the word out for perpendicular, or you can use the mathematical notation for perpendicular. If we look at the third line, what's the slope of the first equation?
2.
Thank you. Does everyone know where she's getting the 2 from?
Yeah.
Because it's next to the X.
It's next to the X.
Or variable.
Correct. Now when we look at the second one. Is this the version that I can tell you what the slope is right away?
No.
No, this is standard form, which is what we learned about last class. Does anyone remember that shortcut for the slope?
ABC.
Opposite of what over what?
A over B.
Opposite of A over B. So if I do opposite of A over B, what's the slope that I'm going to get? What's the opposite of A?
Positive 2.
Positive 2.
Over 1.
And B is 1. So 2 over 1 is the same as 2. So these two lines, what are they?
Parallel.
Parallel. Now let's say we weren't 100% sure about this. What could we do with these two equations?
Put them on decimals.
Let's do that. Let's put them on Desmos and let's see what they come out to look like so we can guarantee ourselves that they're parallel or perpendicular. Now remember, Desmos is smart enough to graph from standard form, so we can just type it right on in. I see people are already getting ahead of me and I love it. Go ahead and type back on our notes here. Number 4, what's the slope of the top one on number 4?
-3.
Thank you. What's the slope of the bottom one?
-1/3.
Okay, how are these two slopes related?
Because they just flip.
They're flip. Okay, so they're not parallel because they're not the same. Are they perpendicular?
Yeah.
They're both negative.
They're both negative. Remember, it has to be an opposite reciprocal, which means they have to have different signs, and then the flip fraction. This is a flipped fraction. 3 over 1 is the same as 1 over 3 when you flip it over, but these are both negative. So guess what?
Parallel or neither.
This is neither parallel nor perpendicular. Those words only count when there is exactly the same slope or it is exactly an opposite reciprocal. If it's just a regular reciprocal, like, okay, cool, but it's not parallel or perpendicular. Let's prove this for a second in your Desmos. Go ahead and type those in. It should not look like it meets at a right angle, nor should it look like they're parallel lines. Let's go look at Desmos. All right, number 5 is y'all's. I want you to tell me if these two lines are parallel, perpendicular, or neither. You start by listing out the slopes and then telling me how they're related. It should take like 5 seconds to do these kinds of problems. All right, so I'm hoping on number 5 you said, well, Ms. Quigley, the slope of the top line is -2, and the slope of the bottom line is 1/2. Is that what you said? And now, how are these lines related?
They're
What's the word? You gotta say the word, or else we don't know what it is.
Perpendicular.
These are perpendicular because their slopes are opposite reciprocals. Okay? Perpendicular. Say perpendicular to yourself right now.
Perpendicular.
Tell your shoulder partner that perpendicular lines have opposite reciprocal slopes.
Opposite reciprocal slopes.
No, say it. Don't just say yeah. You gotta say the words out loud, or else you're never gonna remember them. Okay? Now we've got number 6. Number 6 is kind of a challenge question here. Does anyone remember what kind of lines number 6 are?
They are
Ooh, there's one of this one's definitely a Vux line because it starts with x equals. So if we know it's a Vux line,
there's a void.
what kind of slope does this one have?
Undefined.
Undefined. Okay, so I'm going to write undefined down here. And we know that undefined numbers are undefined because we have some number. I'm going to pick -1 on purpose. Divided by 0 because you can't divide by 0. That's why it's undefined. Okay? What kind of line is this one?
Void.
This is a Hoy line. What kind of slope is a Hoy line? 0 slope, which is the same thing as saying 0 over some number. What do you now notice about the slopes that are 0 and undefined?
They're flipped.
They're flipped fractions and change signs. That's why I picked -1. So these two lines, yes, they are perpendicular, which makes sense because if I have a horizontal line and a vertical line, don't they have to meet at a right angle because of the way horizontal and vertical works? Oh, snap. We know these things. We know that Hoy and Vux lines have to have opposite reciprocal slopes. You just didn't know they were called that before today. But you know what? In case you forgot this fact, Desmos can graph both of these lines, and I want you to go prove it to yourself. Please go type these two lines into Desmos so you can see that I'm correct. That way you don't just take me at my word. Nothing we're going to do on the rest of the notes is new. It takes a little bit of what we learned today and plugs it back into the things that we've learned before. And this might have been a lesson that you were question marking. So maybe today's the day it's going to stick. We need to be able to, by the end of the day, write equations that are parallel and perpendicular. That's our goal for today. This is the kind of example we need to be able to do by the end of today to feel successful. Okay? There are 3 very easy steps to do this. It's going to ask us to write the equation of a line in slope-intercept form that passes through the given point and is parallel to the given line. I want you to highlight the word parallel right now. I bolded it and underlined it for you, but I want you to highlight it. We know that parallel lines have the same slope. So our first step is to simply identify the slope of the given line. I want to know what the m is that they gave me. And since it's parallel, I'm going to use the same slope that they gave me. And I'm going to plug that in to point slope form. If you look at your formula chart, actually look at your formula chart. For point slope form, it's number 10 on my formula chart. And it says that point slope form, we're going to write it down, is y minus y1 equal to m x minus x1. Y'all remember using that formula?
Yes.
It's coming back. So if we didn't know how to use it before, today's the day to learn it. We're going to use that formula, and then all we're going to have to do is rearrange to make it in slope-intercept form, which means we're going to distribute and then use inverse operations. 2 very easy steps. Okay? Follow along with me on number 7. We're going to do these 3 steps because we want to write an equation of a line that is parallel to this one that they gave me and goes through this point. Well, if I know it needs to be parallel, that means the parallel slope that I want to use is also that slope. So what slope do I want to use here?
1/3.
That's correct. I want it to be the same slope because it has to be parallel to that line. I literally don't care about the end of this equation because I need its slope only. Okay? Then if I have a slope and I have a point, isn't that enough information to plug into point slope form? Okay, so let's do it. We see the equation on our formula chart, / we just wrote it on our notes. So we are going to plug in y minus y1. What's y1?
-1.
Okay, so what's minus -1? What do I write down?
1.
+1, because it's minus a negative, equal to 1/3, that's m, x minus 3. That's what we labeled as x1. Does everyone know where I get the numbers from? If you don't, I'm not going to leave this up here the whole time, but this is what I'm doing. I'm taking the x1 and plugging it where the x1 goes. I'm taking the y1, plugging it where the y1 goes. I'm taking the slope and plugging it where the slope goes. That's where I'm getting those numbers from. We're done with step 2. All we have is step 3, which is rearranging to slope-intercept form. Distribute. Distribute. Distribution is multiplication. What's 1/3 times x?
1/3 x.
Cool. What's 1/3 times -3?
Wait, -3x?
-1. You would check your brain or check your calculator, am I right? Okay. The last step is to use inverse operations. What kind of inverse operation am I going to use here? I want the y by itself, so what do I have to do on the side?
You have to
Distribute.
There's no distribution.
Subtract.
Okay, yeah, I already did the distribution, so I will subtract the 1 from both sides because that'll get rid of the 1 on the left side. All that I have left then is y equal to 1/3 x. And then -1 minus 1, which is -2. Here's what I think the answer is. Okay, this is an equation that we think is parallel to the given line and goes through the given slope. But there is a way to check our work and to use a multiple choice test to our advantage. Okay, we know what this is supposed to look like. We know that these two lines should look like carbon copies of each other just moved around, or they should look like train tracks. We also know that this line should go through this point. So why don't we just check and make sure that that happens? On your Desmos, I want you to type in the entire question that it gave you, including the equation, press enter, type in the point that they gave you, press enter, and then type in what we think the answer is. And if visually this line that we got goes through this point and is parallel to that line, we did it right. Let's go see and make sure we're correct. So join me on Desmos, if you will. So we're working on number 8 on our own, trying to write the equation that is parallel to that line, goes through that point, and then we will check our answers on Desmos to make sure we're correct. Let me get you halfway there. If you got stalled at the very beginning, I need the same slope because I want them to be parallel. So my slope that's parallel should also be 7/2. Did we get that far?
Yes.
Then we also know that this is x1, y1. Did we get that far?
Yes.
And then we're going to plug it into that equation using only the numbers in this given question. So we should have y minus 2, because that's what I labeled as y1, equal to 7/2 x minus 0. Okay, pause. If you have not finished this question from here, I want you to keep going. If you have, check it on Desmos, make sure you're right. And if you've done that, help somebody next to you. For those of you waiting on me to make sure we got this one right, if we distribute, bloop, bloop, 7/2 times x is 7/2x. 7 divided by 2 times 0 is 0. And the only inverse operation I have to do here is what?
Subtract.
What? Which one? The inverse of subtracting is adding. Don't tell me inverse of subtracting is subtracting. Don't make no sense. So I should have 7/2x plus 2 as my slope-intercept form equation. And then we just head over to Desmos to make sure that all of the information they gave me in the question, that the equation and the point makes sense with my answer. That the line I get is parallel to that one, and it goes through that point. So now that we've mastered parallel, we're going to go work on these same set of skills, but in a perpendicular context. So scoot on over to the side that says writing equations of perpendicular lines. It says to write an equation of a line in slope-intercept form. That sounds familiar. It's what we just did. But this time it passes through the given point and is perpendicular to the given line. Highlight the word perpendicular, please. The steps are almost exactly the same. Okay? Almost exactly the same, except this time we're not using the same slope. What kind of slope are we going to use for perpendicular lines?
The flip.
Yeah, what's the fancy words? Close your notes and look at the fancy words. What's the fancy words we're using today? Opposite reciprocal.
Oh, yeah.
Okay. So, on number 11, which is the first one we're doing, they gave me an equation. They gave me a point. I want to write a perpendicular line through that point. So, instead of using 2/3, what's the perpendicular slope that I actually want to use in my problem?
Negative 3 over 2.
-3/2. She just did the opposite reciprocal. Flip the fraction, change the sign. Now that I have a slope and I have a point, I can do exactly what I did in the last couple problems. Okay? I need to fill in the point slope formula. I go look at my formula chart to make sure I write it down correctly. So physically look at your formula chart, make sure I wrote it down correctly. I'm human, I make mistakes. Look at your formula chart. We find the point slope formula because I'm given a point and a slope, and I plug the things in where they go. So with me, we would write y minus 2 equals,
Negative 3 over 2, parentheses, x plus 2 parentheses.
how did you guys get plus 2?
Because it's 2 negatives.
Yeah, it is minus negative 2, and minus negative 2 is the same as plus 2. That is the point slope version, but 98% of the time, answer choices are going to be written in slope-intercept form. 2 steps to get it in slope-intercept form, though. What's the first step?
You gotta distribute.
Yes, ma'am, we have to distribute. We've got numbers in front of parentheses. First thing I got to do is get rid of that problem. Negative 3/2 times x is negative 3/2 x. And negative 3/2 times 2? Negative 3. You've got a calculator. You can handle for the fractions. We've done the distribution. What's the very last step so that I can have this solved for y?
You gotta add.
Inverse operation, which is adding what?
Negative 2.
Adding 2 to both sides. That's a 0 pair, so it crosses out. And we'd have y equal to negative 3/2 x minus 1. But just like we checked all of our answers that were parallel, we can still check these answers in Desmos to make sure visually that they show up as right angles. So in your Desmos, I'd like for you to check and make sure that the equation we got, or our answer choice, essentially, whatever we got on our test or on our quiz, is actually perpendicular to this line and does actually go through this point. Can you guys do that for me? Thanks, friends. You're going to find me the perpendicular line to number 12 that goes through that point. I want you to write the whole equation and then check yourself on Desmos. If you finish and you're pretty sure you got it right because you checked it on Desmos, if you would please help your neighbor or your shoulder partner out, that would be awesome. All right, for my friends who are stuck, I'm going to start going over it slowly. If I want a perpendicular line, that means I don't want the same slope. I actually want the opposite reciprocal slope. And I saw lots of good things here. The opposite reciprocal slope I should use then is what?
1 minus
Just
negative 2 over 7.
negative 2 over 7. The flip fraction, change sign. I literally don't care about this y-intercept, except for the fact that I'm going to use it to check my work later. I also know that this is x1 and y1. Okay? And now I can fill in point slope form because I have a point and a slope. Here's the point. There's the slope. Now, when I was walking around just now, I saw a lot of mistakes happening because y'all aren't writing down the equation or looking at your formula chart. You're just willy-nilly trying to put things places. If it helps you to write down the equation first, y minus y1 equal to m x minus x1, so that you know exactly where things go, you need to do that. Honestly, please do that. Because that's where we're getting our mistakes, is that we're not filling in the right equation. Now that we have everything labeled, we know where it should go. This should be y minus 2 equal to negative 2 over 7 x minus 0. Thank you. That's the point slope form. Sometimes answer choices will be written that way, but majority of the time, they're going to be distributed and moved around to slope-intercept form.
Negative 2 over 7x.
Plus
0.
Correct. And so what do I do to use inverse operations?
You add 2.
Add 2 to both sides. This would be y equal to negative 2/7 x plus 2. Those of you who checked it in Desmos, did it show up as a perpendicular line
Yes.
that met at a cross, and did it go through that point that you put on the screen? Then you got it right. If it doesn't, don't choose that answer choice. Or don't say you're done with your problem because you have not gotten it right. That's the only way that it's right, is if it meets those criteria and shows up that way.